Welcome everyone to an invitation to learning engineering. This is our second in this series, and this one is hosted by the higher education MIG. So we'll kind of talk a little bit about how learning engineering kind of sits within the framework of higher education. But yeah, if you've been wondering what people are talking about when they're talking about learning engineering, this is a great opportunity to kind of be introduced to it. And also, if you're coming from a higher ed context, kind of see what it looks like in the space of higher ed. This webinar is brought to you by the ICICLE community, and we'll have a little chance to introduce who ICICLE is in a little bit as we go along. I'm joined here by my co-chair, Emily Marasco, who's joining us from Canada. So we're grateful to have her, and the two of us will be kind of talking through this first part before we introduce some of our fellow speakers. So just in terms of agenda, doing a little bit of welcome. We'll do some introductions about who we are in the higher ed MIG. We'll talk about how learning engineering sits in higher education and what that looks like. Then we're going to talk through some kind of learning engineering tools in practice from our colleagues at MIT. And then we are going to hear a case study from our colleague Marilu. Then we'll have an opportunity to do some questions and answers. And then we'll go through the ICICLE SIGs and MIGs and talk about what those are about and provide some other resources for you, along with an invitation of ways that you can get engaged with the work that we're doing here. So Emily, do you want to talk a little bit about what the higher education MIG is all about?
Yeah, thanks, Rob. So, like Rob said, today's context is looking at higher education, post-secondary education, and how learning engineering can be a valuable tool, process, integration into that application. And so, our higher education MIG, we meet once a month. Rob and I are the co-chairs for that group. And it's a very interdisciplinary group. So we are a mix of faculty members, admin, active educators, learning architects, instructional designers, educational specialists, researchers. So some of us are using learning engineering, some of us are studying learning engineering. So very interdisciplinary. Sometimes people are looking at contexts for higher ed within industry or looking at how we can bring K to 12 into post-secondary. So again, very, very wide ranging applications. And we really have three themes as a group. How do you identify where learning engineering is? Because some of us are doing learning engineering without realizing that it's learning engineering. How do we get more visibility on learning engineering? And today's webinar is part of that. And then third, how do we collaborate? Are there cross-institutional research opportunities or presentation opportunities? Being in Canada, I don't have the same wide-ranging network of learning engineers here in Canada, so it's been very valuable for me to collaborate with various experts in the US, and we have various global contacts as well. So if you'd like to join us, that is our QR code. We'll talk more about the SIGs and MIGs at the end of today's webinar, but we're looking forward to sharing some of the great work that our members have been doing. And I'll pass it back over to Rob.
Great, thanks, Emily. Yeah, so we would recognize that since this is an invitation to learning engineering, that many of you may not be super familiar with what learning engineering is. You'll see this definition that we have here that's kind of been endorsed by the ICICLE community, and that is that learning engineering is a process and a practice that applies the learning sciences using human-centered engineering design, methodologies, and data-informed decision-making to support learners and their development. So you'll see a lot of kind of different elements of that, but we'll also, you'll note that we've highlighted that it's a process and a practice. So it means that, learning engineering can be something that you engage in doing, the process of learning engineering. It can also be, something that you might have an individual that is a learning engineer. So I know that I think we had a few Carnegie Mellon learning engineers in the meeting today. So it's great to have you. But we really try to emphasize that it's as Emily said, kind of an interdisciplinary process that involves a lot of different stakeholders with a lot of different expertise kind of coming together to engage in the process of learning engineering. And then, if you are interested in learning engineering and want to dive into a little bit more, we definitely recommend Jim Goodell, who's a member of our community. He edited a book called The Learning Engineering Toolkit. that came out a few years ago. And in that, he kind of outlined some of the different parts of the learning engineering process. And many of the people who are involved with the ICICLE community are contributors to that book. So kind of going back and thinking about how learning engineering emerged, it really kind of came out, the concept of learning engineering came out of the work of Herbert Simon. He was a Nobel laureate and the president at Carnegie Mellon University. And he envisioned this idea of having a team of individuals that are working together to improve learning. And he called these individuals learning engineers. So kind of from that, we've really seen this concept of learning engineering emerge. And from the higher ed perspective, we've seen a lot of it being fostered in the higher ed environment. Obviously, Carnegie Mellon, they have learning engineers. They launched the Simon Initiative, as seen here in 2014, to harness cross-disciplinary learning to develop this learning engineering ecosystem. In 2017, IEEE, which is a standards organization, created ICICLE, which is I always have to look up the name of it. It's the International Consortium on Innovation and Collaboration for Learning Engineering, and that is what ICICLE is. So that's who we are. We're a part of IEEE, but we work together to collaborate on bringing learning engineering forth. So then we adopted a definition of learning engineering. 2023 Learning Engineering Toolkit was created. And then you'll note here on the last, in 2023 also, Arizona State University developed the Learning Engineering Institute. So that's kind of another example of higher education institutions embracing this idea of learning engineers. We've also seen other institutions who are hiring learning engineers or who are interested in engaging in the learning engineering process. So, Emily, do you want to talk a little bit about kind of broadly who kind of composes the ICICLE community?
So as a group, ICICLE really formalized in around 2017 and has grown since then. So as a whole membership, ICICLE members are committed to developing learning engineering as a profession, as a practice, as a process. So like we said, in the applications, it could take various forms. And we have a wide ranging degree of sectors who get involved, from K-12, higher ed, government, military, corporate, academia. So it's a wide interdisciplinary and cross-disciplinary connection between all of the various contributing members. And of course, we all have different roles. And I'll show you in a second why the roles are so important in in learning engineering. We've been meeting on a monthly basis since around January 2018, and some of the SIGs and MIGs have undergone various transformations. Some are newer, some are a little bit older, some have changed throughout the years. And those are great opportunities to look at learning engineering from different perspectives, whether it's how to design using learning engineering, what tools are used in learning engineering, the skills that are needed, how to apply learning engineering across all these different applications, contexts. And again, we'll show you how to join at the end of the session. I mentioned roles, which is a part of this shared understanding. And this is one of my favorite graphics about the learning engineering process, especially because in a post-secondary context or a higher ed context, sometimes we find ourselves taking on more of these roles ourselves. If you are an educator in a classroom and you're teaching by yourself, and maybe you have a teaching assistant, but really you end up being the subject matter expert. And if you're studying your class, maybe you're looking at the assessment, measurement, and evaluation. Maybe you're looking at the learning experience design, looking at the data science and the learning science, and it can be very overwhelming. And the nice thing about the learning engineering process is that we break it down and start to help you find the resources and the collaborators and the experts that can help fulfill more of these roles, and people who have a stake in the learner's outcomes. So we say that everything funnels through the learner at the bottom. So they're the leaf, and this flower is the analogy for bringing together all the different areas that are very crucial to that educational experience. There's lots of different fields that overlap with learning engineering, whether we're collaborating, have shared understandings. So that could be cognitive science, learning technologies, technical standards, data science, user interface design. Myself, I am a software engineer. So looking at the overlaps between the technical side of engineering as well as the data science and collecting measurements from students, but also teaching students about software engineering. So it's very, very interesting to see how this team comes together. And ultimately, again, the goal is always improving that teaching and learning experience and the outcomes for our learners.
Thanks,
Let
Emily.
Rob go into the process itself.
Yeah, so Emily has talked a little bit about kind of the who of learning engineering, who is involved. And this is a representation of the learning engineering process. This is also included in the learning engineering toolkit and was conceptualized by members of our community, including Aaron Kessler, whose team from MIT will be speaking soon. But the idea is that learning engineering kind of starts with a central challenge, right? It is the thing that you are trying to address. And it can kind of go from the central challenge. You will create, you'll design, develop, and instrument some kind of solution, right? And a key component of this is the going along with this is that as you're developing these solutions, you're also instrumenting data collection. You're trying to find ways to determine whether or not that solution that you've proposed is working, or ways that that solution can be improved. And so you'll kind of see this cycle of going from creation down to implementation to investigation. But you'll also note that this continues to cycle around, and there are many entry and exit points from this process. So it's implemented with real learners in real contexts. There's drafts and prototypes, iterations, and then we're also doing data analysis to see the effectiveness of the way that these tools work. And someone coming from higher ed, this is something that I think is pretty natural in the way that we develop courses, right? We may have a new concept for, hey, I want to develop a course that does this thing, and we use, so we implement it, or maybe working with team members to implement those things, and then we're kind of looking at data to look at the effectiveness of how well that idea worked. The learning engineering process really scaffolds that to make sure that we are considering kind of all of the components, right? To ensure that we're engaging kind of continuous revision of those solutions that we've developed. And one last thing I'll just kind of say is just that emphasizing that all of this kind of involves data. I think that's something that's really important, that I think that the learning engineering process really emphasizes, is the unique role that data kind of lives in this process, right? If you're kind of familiar with like traditional instructional design models or ADDIE, right, we kind of tend to look at evaluation kind of coming at the end. And as someone who has worked as an instructional designer, I know that oftentimes that kind of gets left out of the conversation, right? It's like, hey, let's evaluate, let's implement it and then evaluate it, and then we kind of never circle back around. So just placing the emphasis on that data can be really important to know, are we headed in the right direction, and knowing that we're also going to kind of circle back and cycle through this whole process. So it's iterative, data-driven, and outcomes-focused. And then Emily, you want to kind of just talk about some further examples in the higher education context?
I'm going to set the stage for our speakers today. And since we are talking about learning engineering within a higher education context, there's lots of ways that we could find the learning engineering process and the collaborations that we see here helpful, whether that's supporting teaching and learning practice, individual course development. It could be curriculum and program level development, which is something I'm looking at right now. Could be tracking evidence and outcomes for change management, which is something that many higher education contexts suffer a lack of. As well as professional development for faculty members, educational consultants, instructional designers, people who are working within a higher ed context to improve that teaching and learning experience, and would benefit from having another tool or formalized process that would help them understand their challenge, incorporate the data, and learn from it. So our first speakers are going to look at how do we document this work, and what are some tools that could help support us in using learning engineering.
So yeah, we'll turn the time over to Lauren. So I'm going to stop sharing my screen, and Lauren's going to take over. Take it away, Lauren.
Great. Hi, everyone. I'm reporting here from MIT in Cambridge. And yeah, to follow along what Rob was introducing with the learning engineering process and that central challenge, and then what Emily was talking about just now with all the different types of contexts that you might have coming from higher ed, I'm going to talk a little bit more about the ways to go about addressing that central challenge for learners and learning with some insights from myself and Erin's own context here at MIT, but hopefully you find the tools that we talk about may be applicable to your context as well. So just to take a step back, addressing a challenge often means you have to navigate a lot of complexity, right? Rob started talking about all of the different components that you have to keep in mind when you're sort of navigating the learning engineering process. And that's definitely true in the work that Erin and I do. So we are on the residential education team here at MIT, and we help faculty and instructors to improve their teaching through the use of digital technologies in their teaching that happens here on campus. And so our team is always engaging in different types of design for learning projects, but it's definitely not always as straightforward as designing a single course or a single learning experience. In fact, we've had several projects recently that involve things like designing a whole enrollment and outreach strategy alongside a learning experience that we're designing, or even more recently, and this example will come up later, designing a whole program with all different levels that has to do with improving the design of courses that faculty come to us with. So basically woven into our context are all of these additional things that we have to factor into us navigating the learning engineering process and to factor into our design work. So in our specific higher ed setting, this includes things like the technology that's available to us, and this comes with its own set of affordances and constraints that we have to work with, and also data sources. We have different data streams coming from the different tools that we use. Also, what I kind of call layers of learners. In our particular context, we design both for instructors, for example, to help them integrate technology into their teaching in pedagogically sound ways. So they become our key learner audience. But we also design for MIT students as well, often in tandem with these instructors. We also have organizational sort of expectations, policies, cultural norms, which I'm sure is the case for all of you, depending on your own context. So that just means generally understanding and factoring in the landscape in which your design work is situated, but other things too. For us, for example, we also have to sort of be aware of the unique makeups of each academic department here. We're also working on a learning engineering team where we have distributed expertise, and we sort of have to come together around the central challenge with these different, areas of expertise that people have. And you can think back to that flower diagram that Emily showed us earlier, really keeping our eye on making sure we have a shared understanding of what we're working on and not staying so siloed from each other. Then other factors like timelines, we have some projects where we have to get the bulk of the work done in 3 months over the summer, and other projects where we've been maintaining and sustaining certain resources for years now. So that could be all over the place. And then also things like budget as well, that tends to be a pretty common constraint in higher education as well. So how do we keep track of all of these things? We develop tools that help us navigate our complex contexts, and we've developed them with the learning engineering process in mind, and sort of what we like to call a learning engineering mindset. So I'm briefly going to talk about 3 of those tools that we use and that many of you may have already heard about or maybe even use yourselves, before transitioning over to our next speaker, Marilu, who's going to talk about how she uses these tools in her context. So the 3 tools are the Learning Engineering Evidence and Decision Tracker, or a LEAD tracker, which is basically a tool, a document where you write down your design decisions and the justifications behind why you made that decision, really just to get it out of your head and make it transparent. The second tool is sort of a tool and a practice combined. It's annotating that learning engineering process visual representation that we saw earlier, which then developed into a more scaffolded resource that we call the LE case guide. And this is a helpful tool in practice to really interrogate your context, map out all of the pieces and components, and see the connections between them. And then the third tool is sort of an evolution of annotating a single learning engineering process representation, and we call that annotating nested LEPs. And this is a way to unpack and interrogate multiple but related LEPs and sort of, still drawing connections, but really zooming in and out on the details there. And so, to be clear, Erin and I did not set out to develop any of these. Like, we didn't just sit down and say, like, we need to make a tool. Like, they genuinely came about because they helped us along the way with our work, and they continue to be our go-to tools. So, why is that? I'd boil it down to because these tools they're tangible. They're good for getting things out of your head. They're good for interrogating and questioning your context, and they're good for institutional knowledge as well. You can share them with others, which I think is pretty valuable. And they're revisitable. So these tools are meant to stick with you throughout cycles of design, throughout multiple cycles of the learning engineering process, throughout implementation and iteration, and they help you be systematic throughout all of that. So just to give more of a preview of each of the three of these tools, we'll start with the lead tracker, which, yes, really is as simple as what you see here. It is not filled in. It really is just sort of a blank table template that a lead tracker could look like. But if you scan the QR code, and I think in the chat, there's going to be a link to some actual filled in examples coming from our MIT context. But basically, yeah, it's this tangible artifact where you write down design decisions and the reasons behind them and other sources of influence behind them. Basically, any evidence that supports the way that you enact design decisions. It's really a tool for turning evidence that you collect here into action. And it's something that you return to as your context shifts over time. So, if we had to distill it down to sort of three key affordances, lead tracking is a great way to make your decisions and justifications concrete, and that can be really helpful to ensure that you're making pedagogically sound and contextually sound decisions. And the decisions that you write down also then become entry points to iteration. So maybe that's supported by new evidence that you collect. Maybe, as Rob was saying, you intend to instrument to collect data. Maybe when you get that new data, that influences you to update a decision or create a net new decision, but you have the record of all of them already written down here. And then really it's this explicit evidence and the reasoning behind it are great for guiding any conversations and communications with the greater learning engineering team, with other stakeholders, because you have it all written down and it's a shared artifact amongst everyone. And then the second tool/practice is annotating the learning engineering representation. So like lead tracking, we just find that writing things down and visually mapping things out is very helpful to our work. So another way to do this is to take the learning engineering process representation and actually fill it in, write in it, annotate it, do it at the level of each piece of the LEP. You can see we actually filled out all of the little bubbles here, plus we added some things. But if you're doing something like this at the beginning of a project, like before you're getting started, it can help you plan and ensure that you're considering all of the contextual factors, learner needs, implementation plans, things like that, so that you make sure you include it in the design of your solution. If you do it along the way of your design, maybe the work is already underway, it helps you interrogate the choices that you've made so far and maybe incorporate any initial feedback you've gotten. It might lead you to change something sooner rather than later. And then if you do it retroactively, which we've certainly done before, like after we've already launched something, it really helps you reflect on what you did and helps you move forward. So it's kind of, we find it helpful along any step of the way, really, whatever works best for you and your team. And I just want to call out over on the right here, you can see that some pieces that we added that are not in the original LEP representation are little tables that represent the design decisions and justifications that are pulled from the lead tracker. So you can see that there is definitely crossover in the tools that we use. And so given our experience engaging in annotation and along with the learning engineering processes, the visuals utility for others in the community, the Learning Engineering Case Guide 1.0 was developed. So together with Aaron and Amy Parent, who is Aaron's Design SIG co-chair, and Jim Goodell, with incredibly valuable feedback from the Design SIG and others in the community, this guide scaffolds you through the process of filling out the LEP visual and capturing what's in your context at a high level. And so as a tool, it serves as a way for you to better understand the work that you've been doing, and really just using learning engineering as the guiding framework for that. And it gives step-by-step support. So I just included a little snippet of, one of those steps in the guide. But really, you can start anywhere that makes sense for you. We're not overly prescribing, like, you must start by filling in this box. Like, whatever works for your context is just meant to prompt that sort of reflection that we find to be helpful. And additionally, I would say that another affordance of using this tool is it also provides a way to systematically capture the work that the community is doing, this community of learning engineers, so that we can continue learning from each other's use cases as well. And then finally, the third tool that we use, like I said, is an expansion upon the idea of annotating a single LEP visual. And it came about because a few projects on our team that we had to tackle required us to enact designs in like pretty complex contexts where we were trying to implement designs and changes across larger sets of programs at our organization involving many different organizational levels. And again, I think that might resonate with some of your higher ed contexts as well. So anyway, at this level of complexity, we realized that we were actually dealing with multiple learning engineering processes that were concurrent and sort of nested, but with their own cycles and contexts, but ultimately all stemming from the original challenge, which is why we sort of use the word nested for this. So just for a second, think about your own challenge, a challenge for learning and learners that you have, and think about the LEP visual representation, the case guide that we just showed. Maybe you even have one of those little like sub-challenge bubbles stemming out from the central challenge. For you, does that like spin off into another layer or level that constitutes its own LEP, but that's connected to the central challenge, or maybe the overlap is somewhere else? Maybe you have some shared data source and there are overlaps that are happening elsewhere. And basically, I want you to think about visually, what would it look like if you were to annotate all of those things? Like visually, what would it look like? What would it be like for you to draw connections? So for us personally, we came up with something that looks like this, basically just stacked, nested, original learning engineering processes. And this is more of a starting point for thinking. But then in terms of using this tool like as a practice, we would annotate the individual LEPs that we're dealing with, for whatever the project context is, and fill in all those details using that case guide structure. And then we zoom back out from all of those granular details and we sort of arrange however many LEPs we have, however many circles we have, sort of like arrange them in a physical space and draw connections among them and between them and see where the points of overlap are. We find that this practice, like all of these steps all told, gives us a way to get a systems level view of our design work, but also be able to zoom back in on those individual details and connections. it really, like, ultimately it is about figuring out how all of these things are interconnected and sort of cutting out the noise when you're in a very complex context. That's a big part of our work. And, we feel that that could be a starting point for you to use learning engineering to begin to unpack your own context. So we wrote up a case about how we planned cycles of a course redesign program here at MIT, and we put it on a poster, which you see here. And Erin and I presented it at the last ICICLE conference last summer. And that's where we met Marilu. And we talked about how she might be able to adapt these tools into her own context. So we'll have her share her example next. Thank you.
Thank you, Lauren. Hello, everybody. I'm gonna share my part here. So, as Lauren says, last summer, I was sent by my boss, the CEO of the Western School of Business, the CPA Western School of Business, to find out what was learning engineering about. And because he hired me as an educational research and development person to figure it out, how can we innovate in the school. So the challenge was big because the school had already many different pilots running, and so everybody was innovating, but there was not an organization of data. It was kind of like very spread across. And when they were asking for results, nobody knew things. It was pretty all over the place. So I went there, and among all the presentations I heard, Lauren and Aaron presentation caught my eye because it was pretty useful for a very highly complex environment. So this is my presentation on that. So the CPA Western School of Business, I don't know if you know, but in Canada, the Chartered Professional Accountants are one single organization. And so they have different ways to educate. Okay, sorry. But time into updating. Okay, so in Canada, the CPAs are one single organization. They are divided by Western, Atlantic, Ontario, Quebec. So they have their own schools or ways to educate the people that want to pursue the CPA certification. And so the Western school has around 15,000 learners, and the programs are offered for candidates, people ready to get into the certification, and for preparation to the certification as well. So when I started working there, I observed that for the process of innovation, there were already staff in running trainings of design thinking. And so one of the main situations I faced, it was you cannot remove design thinking from whatever you are going to innovate. And so I came up and I figured out that design thinking it was pretty much possible to be inserted in the learning engineering process. And even more, at that time, design thinking was pretty ambiguous for many people. They were really struggling how to innovate with design thinking. It was, okay, they were not really able to solve things or to show advancement following that framework. However, learning engineering process, it was much more simple and it made much more sense. And so here it is the cycle, right? Creation, pilots, investigation, and we can start depending. Some pilots were already running, so we started by pilots. Some other ones needed to be created, and some other ones needed to be investigated first to see what we can do. And so one of the main things here, it was that I am a learning scientist. My CEO was totally committed to place the needs of the learners at the center, and that matched perfectly with learning engineering. And so we started by research and development mini cycles. So at the school, we have this creation of mini cycles first. The mini cycles take around 1 semester length or 1 course length. And once is already run, we can implement or scale. For doing this process, one of the main things we needed to do is to create a set of data instruments and some kind of data dictionary, and scheduling that when this data is going to be collected along with the mini cycle. And so having that, it also gives us the timing on when we can implement that at scale. And the other thing that helped us is to observe which ideas are not scalable. And so how can we modify, adapt, or make them scalable? So one of the things that is beautiful about learning engineering is that it says, this is a quote from the book, it is aligned with the time, path, pace, place, choice, and voice of the learners, and adaptable to complex educational settings and to scale. So all these ingredients were a mandate to follow and to provide resources, solutions. So that was kind of like, for me, ding, the perfect match. And so when I went to that conference, I saw so many conferences, I told you, and actually, the first day this nested innovation poster had to be shown, they didn't arrive on time because some problems with the flight. So they arrived next day. And I was kind of like, oh, I miss it. I wanted really to see it because I read the little extract and I said, okay, that's very interesting. And so I followed them next day, they arrived. That was a lucky thing for me. And so it was like a perfect match. So this is Aaron's and Lauren nested schema applied to the school. You see in the top of program level, this is the beauty of this is, for instance, in my context, the program level, it's something that the CEO and the executives can focus on. So you have here in this part the details, but let's see, to make it easy, at program level, that's what is important for the CEOs and the executives, like general overviews, like how things are going, are we advancing, and how can we provide more support. They don't need like 60 pages report, they need 5 pages overview, and are we going well? Yes. Why? Because this data is saying that. So the data is pretty general. But at community level, that is in the middle, it's more concerned. This is kind of teams providing support for specific communities. That's to say, indigenous learners, international learners, learners from specific provinces in Canada. So these teams are more focused on that middle level data. And so they don't need to know details as well, but they still need some more robust and detailed data than the top level. And also then we have the third level here, intervention level. This is like depending of what intervention we are providing. For instance, we are providing coaches supporting specific groups, or we are providing cultural related instructors, providing guidance to and teaching to specific groups. So an intervention, people that are working in that detailed, very targeted focus groups, they need that detail. They need to know what people are saying in their courses, what are the opinions, what are their concerns, how they can help better, how can they support better. So the beauty of this schema is that different people can focus at different places, whereas my research team can focus at the place we want to provide data. So it's kind of like automatically giving us the clue where to go, how to do it, and who may need the different levels of detail. So for instance, you see here also the team related to program level. It included some learning innovation stuff. In the case of Lauren and Aaron schema, they play some technology innovation support or something like that. Lauren, I don't remember the name of that person in your schema, so I came out with another name. But in the top level, here are subject matter experts. This is like scholars and experts from computational science, and like highly educated people with a lot of experience, also like high paid hours as well, but also we need community level support. These are contractors with experience teaching different groups of learners. And we have also at intervention level, we have instructors, we have coaches, we have former students that can help to serve as a peer support. So depending of the level, the learning innovation support additional contractor that we are hiring already provides that detail of support, either at top level or even at intervention level. So I'm going to share here with you the next three charts that is called the LEP representation. So at the top, at the program level, I see it from complexity. We call that aggregated level. So an aggregated level, the cycle is annually. The cycle that goes through is annually. And also the goals are stated in the school's business plan, and this has 3 years long term. This is revised yearly, but the goal is at 3 years. So that's to say this cycle runs slow compared with the intervention level. So in this level, it is, yeah, my time is almost over. Anyway, key decisions at this top level, what we do and what are the tools we use and how we provide information at this level. It is also related with general and aggregated aspects of the data. So we have also at mid-level, this is the target community. We can have supervisors working here. We have the contractors. This is specifically to support different communities, minorities, or provinces with specific problems or struggles, fires or something in the way, right? So this is implemented, and this is also run annually. And most of them has a logic model that the last or the top intent of the model usually is 3-year period as well. The goals are revised yearly, but it is expected that the outcomes of that and the impacts of that is going to be a 3 years length. And we have also the learning and individual at individual level. In this case, our intervention level. So the intervention level is all the little support that we provide to the learners, like financial support, like allocation support, like special needs support, coaches, instructors, cultural related knowledge, and so on. So this is a cycle by semester. So, and all the data is collected at the end of the course, and it creates, at the end of the course, is informing the new creation, or the new creation of a pilot or another cycle, or if it's already successful, it is implemented right away. So we call it immediate, no, we call it, but Lauren and Aaron place it there, and it's totally applicable to the school as well. There are some results or some findings that comes as immediate refinement. They go right away to be applied to the whole school, or extended refinement. That means that it's gonna be done another cycle, or maybe another couple of cycles until we scale that. All these things also considers resources, cost, hiring people. We use the lead tracker, and we also create the data instruments and how to collect that thing. So I'm gonna be very short here. And this is the nested process applied to one of the most complex programs we have, the Indigenous Learners in Accounting. So as you see here is the top program level, community level is the Indigenous people in Canada. And the intervention level in this case is not 1, but 15. So that's the complexity we have. We are collecting data simultaneously in one semester from 15 interventions. And so this nested allows that. And that's why I was like, no, this was the solution of my problems at work. So we are running the same process, for everyone, like financial support, how it is going, what was the pilot, how was implemented. We investigate and provide at the end of the course how it went, what was the result, how much was it used, and also, we also run facilitated discussions. So we provide not just quantitative data, but also qualitative data. We hear and talk with the students about how we did and how can we improve in the next cycle, or how can we scale it properly. So the overall process and collection of data looks like this. We have currently, we have PEP, preparatory courses, and courses for candidates. And then we have community levels, and then we have multiple independent independent intervention levels, filling of all the way to the top, to the program level, all the data. The beauty of this is that we use the same data from the bottom to the top. The only difference is that at top level, we provide aggregated data. Mid-level or community, we provide mid-level data, so not that detail, not more detail. And the bottom, we provide very detailed for the teams to improve along the way. However, the school is gonna change very soon. So from now, from 2027, not very soon, right? From 2027, it's gonna be more focused on current candidates, and this part of preparation level is gonna disappear, but not for Indigenous communities. So it is gonna be different, but at the end, the nested process is allowing us to provide that transition smoothly, because it is easy to expand or focus in different activities we are currently running, or also to remove an activity and to see connections across it. So that's all over the process we are doing. And the lead tracker, how we are doing, the only modifications we are using here is, since we are having not one intervention in our discussions, in our meetings. It is up to 15 interventions in some of our programs. So we added one more column that is the related topic. So we will not be lost among what decision was done or made related to what, right? So that related topic was something that we added as an important. And that's it. Thank you for your attention.
Thank you so much, Marilu. As you can see from Marilu's process, this learning engineering process really kind of struck with her and was able to kind of capture some of the complexity that they're addressing at her school. So we do want to kind of transition to some Q&A. So if you have some questions either for kind of the group in general or for Marilu or for Lauren, feel free to raise your hand, or you can come up on camera, or you can kind of place them in the chat. So maybe I'll kind of start with this, seed question for Marilu. You kind of talk through this process. Your boss kind of wanted you to be able to kind of do learning engineering or kind of explore this. What has been the reaction towards those kind of stakeholders since you've kind of undertaken this process and done all of this work?
Yeah, as you have commented to me, and that's totally true. If you see the whole schema and the whole process at once, you get scared, and because it's a lot. And so the key to not scare people is to focus on what they need to know. Let's say to my boss, I talked to him about the benefits of the aggregated level. To the specific teams, I just showed them the mini cycle and how this mini cycle is helping them to run that innovation. The other thing is we also provide and build data tools. And so the data tools are distributed across the schedule of the course. And so it helped us to feed people constantly at different levels, constantly with how is everything going, how are we doing? And so that's to say, it is important for us as researchers to manage it and to lead, but they don't need to know everything, because if you show the whole thing to the people, it creates some fear. But when you focus on what they need to know, it is very clear, and so it is possible to coordinate very well research, data, and improving, innovating along the way.
Yeah, thank you for addressing that, because I think kind of looking at some of these models you have, it can feel very overwhelming. And I guess maybe kind of quickly, I'd be interested in Lauren and your thoughts on, someone who's maybe at the beginning of this process and wanting to get started with kind of going through, documenting a learning engineering case or kind of applying this. Like, where would you recommend that they start?
I would definitely recommend, well, first familiarize yourself with the learning engineering process visual itself. Just get familiar with the single representation, and that you can find in all of these resources in the toolkit especially. And once you're a bit familiar with that, I'd say the very first step is the learning engineering case guide resource specifically, just because its whole goal is to scaffold you through the process. So it definitely, I think, could help out someone who is looking to use the learning engineering framework for the first time around their work. And like I said earlier, the steps are really just there to prompt you to reflect on each piece of the LEP, and not so much like you must do it in this order, you have to check all these boxes. I think like the reason I'm saying the case guide is because it helps you do that reflection, and that's probably the best place for someone to get started, is really just to engage with that deeper thinking around your particular context. And from there, you might find that you're in a situation where it warrants having more than one LEP. And that's sort of, it's why the nested structure came out of the original single LEP, but it's why it's for even dealing with even more complexity. So it's kind of like staged a little bit. Definitely don't have to, even if like, I am dealing with complexity all the time, I have so many layers to my projects. If you're looking to really engage deeply with reflection and annotation and doing all the amazing visual work that Marilu just showed us, you don't have to jump right into like, I need a million different circles on my page to write about. You can start small, and I actually recommend that you start small and maybe take a spin through the case guide.
Awesome, thanks. I do get to kind of our wrap up. And I'd say kind of one of the ways that if this has been intriguing to you and you want to get more involved, as part of that learning process and part of implementing these ideas, we definitely kind of welcome you to join the ICICLE community. We'll just kind of say quickly that the ICICLE community is structured into market interest groups and special interest groups. So market interest groups are those that kind of serve different markets, and special interest groups kind of go across markets, but are different aspects of the learning engineering process or different kind of audiences within or topics within the learning engineering process. So this is kind of like, I call it the waffle diagram of our different SIGs and MIGs. And so if you find something in here that's like, oh, I'm really interested in that, we definitely welcome you to join us in our meetings. So here's the list of the ICICLE SIGs and MIGs. I do have a QR code here, and I think hopefully, Renee, you can put the link in the chat as well. This should link you out to our page on IEEE ICICLE that has a list of all of our SIGs and MIGs along with the time that we meet. And most SIGs and MIGs will meet on a monthly basis, on a recurring basis. So it can be pretty easy to kind of predict when the next meeting will be. Here is a couple of additional resources and tools. You can go to this website here from IEEE with around some resources from ICICLE. Also, the Learning Engineering Agency is another. Sorry, we have a poll here. So a poll pops up, and you can see which SIGs and MIGs most interest you. Please note if you can select those that you want. That information will be used we can reach out to you to invite you to those SIGs and MIGs. So just kind of wanted you to be aware that when you're selecting, we can get that information from Zoom about your participation in that. So there's a couple of other tools. So the Learning Agency has a web page. The lead tracker we've talked about, the LE case guide we've talked about. There's been a recent maturity model that's been published by some members of our community. There's also several books and articles that should be available through these resource pages, and you can see a QR code on the page there if you want to learn more.
Those of you who are maybe intermediate now in learning engineering and want to start sharing the good news with others, if you come and join the Higher Ed MIG, we also have a workshop in a box where if you'd like to give a workshop on learning engineering or what you're doing with it, we're happy to share those resources with you as well.
Yeah, and that's really meant to kind of start, in a higher ed context, start the conversation on your campus about this learning engineering process and get people familiar with it. So I guess kind of at the end, I'll say thank you for joining us today for this webinar. We're so grateful that you came and engaged. Special thank you to Lauren for presenting about tools and Aaron for his contributions to that work. And then Marilu, thank you for spending the time kind of sharing the experiences that you've had with, engaging in learning engineering process at your institution. In the higher ed group, we're really focusing on how do we kind of take the work that we've been doing and documenting into these cases. So if you're interested in seeing what other institutions are doing or how they're implementing learning engineering, definitely come to our meetings and we'd be glad to have you and engage in those conversations. Our next meeting is, I think, actually next week, next Tuesday. So, if you're really wanting to get started and engaging with the community, we definitely welcome you. And here's a couple of links there to joining our ICICLE community. And that's it for the webinar. Feel free to stay behind if you have some questions that you want to have answered. We can probably stay for a few minutes. But if not, we're grateful that you joined us, and we hope that we'll see you at one of our meetings very soon.
Thanks, everyone.